Thank you for joining this presentation. First, let us explore the data. For the air store data, we are given 314 different restaurants, their data on visitor, reservations, their location, and their restaurant type. We are also given a hot pepper gourmet data set, contains 13,000 different restaurants, a lot more than what we need. First, looking at the total number of visits per day, we see there is a jump from June 2016. There's also seasonality to the data set. This is a histogram using the log function. It is normally distributed. Looking at the visit by month and by week, this is the average visit. We can see more visit in December and March. For weekly data, there's more visit on Friday, Saturday, Sunday as expected. For the reservation data, we are not going to use this data set a lot, and so we're going to breeze through that. Looking at the types and location, the air restaurants mostly are izakaya restaurant and suites, and here are the top 10 locations. The HPG restaurants, there's a lot more restaurants in the data set, and their categorization is slightly different. Here are the top 10 locations. And so the actual visit is slightly different than the reservation made as expected. This could be due to making reservation through the Hot Pepper Gourmet site, or it can be just drop-ins where you don't make reservations. Also from the plot chart, you see the differences. This is comparing the HPG reservation and air reservation. Just a lot of NAs not categorized. And so moving on to the model I've used. So for the first ARIMA model, I've created the model so it is a pass-through function. So each of the store can be passed through to generate its own model. And so for example, for this store, it is using a 111 for the not unseasoned factors and 200 for the season factors. As you can see, for the prediction generated, it's a lot more muted than the previous actual data. And here are the accuracy set. For the hot winter model, next, similarly, you pass through each of the stores to generate its own forecast model. The RMSE is slightly higher than the ARIMA model. For the last model, ETS forecasting model, for the same example, we see a slightly different seasonality to it, a slightly higher RMSE, and you use two of the three factors for this store. So because I have three different models for each of the store, I am thinking of combining the forecast. So I would either take an average or take a multiplier of each of the result. And for the further reading, here I have a reading about restaurant and prediction. This author looked at the seasonality ARIMA model and how that is not a very good predictor as some of the other model he used. And second, this reading, I was looking at the hot winter model, the trend analysis, and decomposition model. And as you can see, there are pros and cons between the two. And lastly, this reading is about how to best combine the result of the different models, either through Bayesian combination or just equal weighted or through multiplier. I am still doing some reading and research on how to best combine the three model result. Thank you for listening to the presentation.